Okay, so for example 3, we have y equals x squared. We're shifting it 3 units to the right, and we want to know what the new equation is. So let's first rewrite the equation so it looks more like our vertex form. So how could I write it so it looks more like the vertex form? X minus what squared? 0. Good. Plus what? There's nothing there, so it's going to be plus 0. Okay, and so now we're looking at what we're shifting. We're shifting 3 units to the right. So what am I going to be looking at? Inside the parentheses or outside the parentheses? Good. Inside, and I'm shifting to the right, so what am I going to be doing? Subtracting. So we would have y equals x minus 0 minus 3 squared plus 0, which give me y equals x minus 3 squared. Do I have to write that plus 0? No, I don't. So this would be my new equation. Does that make sense? We have y minus 3 equals 1/3 x plus 2 squared. And we want to shift it down 4 units and to the right 3 units. Okay, first thing we have to look at though is this thing doesn't look like our vertex form. So what do we have to do?
Add 3.
Right, we have to add 3 to both sides. So the first thing we're going to do is add 3 to both sides. And our new equation is going to be y equals 1/3 times x plus 2 squared plus 3. Okay, so I want to shift 4 units down. So what am I going to be doing? Subtracting. And am I subtracting inside the parentheses or outside? This time it's outside. So the first thing I'm going to do is I'm going to rewrite y equals 1/3 x plus 2. We don't know the rest of it yet. Plus 3. And we're subtracting 4. And then we're shifting also 3 units to the right. So what am I going to be doing there? To the right, we subtract. So on the inside, we're going to subtract 3 units. Okay, so then let's simplify it. Y equals 1/3 times x plus 2 minus 3 minus 1 squared, 3 minus 4, negative 1. So my new equation is going to be y equals 1/3 times x minus 2 squared minus 1. Okay, so we have a couple definitions we have to know first. First definition is the domain. And the domain is the set of all x values. Now the set means that it is all of the answers lumped together. Okay, so if you say that the set of real numbers is my answer, that means all numbers that are not imaginary. Okay, so our domain means any x value that we can plug into the equation. Okay, so for a parabola, and then we have range. Okay, range is the set of y values. You guys remember domain and range from Algebra 1? Kind of. Okay. Let's look at just any sample parabola. So let's say this is my parabola. Okay, now the arrows mean that it's going on for how long? Forever, right? Okay, so what can I plug in? Let's call this point 0, 1. What x values can I plug in to the parabola or to the equation of the parabola? Any x value. Are you guys comfortable, first of all, with the fact that a graph is just a picture of all the answers? You got, like a line is a picture of all the answers? A parabola is just a picture of all the answers of an equation that has x squared in it? Okay, So we can plug in any value for x because this parabola goes on forever. We can plug in any value of x. Can we get any value of y as our answer? No. So what we would call our domain here, because we can plug in any value for x that we want, we call that all real numbers, or all reals. What does that mean? That means any number that's not imaginary. What was an imaginary number? Square root of a negative. So as long as we don't have square root of a negative, we can plug it in for x. Any number we can plug in for x. So we call that all reals. But what about range? Now range means the y values. Can I get any value for y on this graph? Yes or no?
No.
Jamie, how come no? Well, we're not shifting the parabola. We're just looking at all of the different points on the parabola, which means since it goes on forever, I can get any x point, right? Because it's going on and on and on. But what about the y values? Can y equal 0? Is that on the parabola? No, it's not, right? Well, the lowest point on the parabola is 0 and positive 1. So can 0 be on the parabola for y? Can negative 1? Can negative 50? Can 20? 20 can. It's probably somewhere over here. So what would we call the range? Any y that is greater than or equal to positive 1. So any y that's bigger than that minimum. Okay, does that make sense? What if my parabola was going downwards? Let's call this 0, 5. Then what would my domain be?
X is less than or equal to?
Less than or equal to what?
Oh, wait.
I can plug in any x, right?
Yeah.
X is still going to be all reals.
Is X always going to be all real?
For the parabolas that open up or down, domain will always be all reals. So for the ones that we're working with right now, domain will always be all reals because they go on forever in the x direction, right? I can plug in any x I want to and I'm going to get an answer. Okay, what would range be here?
Y greater than or equal to y.
Okay, Chaseng says greater than or equal to. Caleb says less than. What do you guys think?
Oh yeah.
It has to be less than, right? Less than or equal to positive 5. Because we can only get y values that are less than or equal to positive 5. Does that make sense? So that's what we're doing for these next couple of examples. So we have y equals